For those watching, I will be providing an analysis on how an electroscope works, as well as demonstrations on charging it through induction and neutralizing it through earthing. So, firstly, let us look at how an electroscope detects charge. For this demonstration, I will be using a polythene ruler as to give it a negative charge. Upon rubbing, the electrons from my dry, damaged hair gets transferred onto the polythene ruler, thus giving it a negative charge from an excess of electrons, and my hair, a positive charge from a deficiency of electrons. So, we can see that as the negative charge of the ruler approaches the wire, the aluminium leaves diverge. And the reason for this is greatly affected by the fact that opposite charges attract and like charges repel. The neutral wire has an equal number of protons and electrons, and as I move my negatively charged ruler closer, the electrons are repelled away from the top and accumulates at the bottom of the wire, giving that section a negative charge. Why? Because like charges repel, and thus we have polarized our electroscope. Now, for those wondering why the protons weren't attracted to the negative charge of the ruler, only electrons move. And thus, both our aluminium leaves have been negatively charged, causing them to repel and diverge. Why? Because they are like charges. And as I move the negatively charged ruler away, we can see that the electrons move back into position, causing everything to be neutral once more, and our electroscope is no longer polarized. This time, I'll be putting my finger on the plate and moving the ruler close. As you can see, there is no reaction, until I remove both my finger and the ruler's negative charge. The leaves diverge. This is due to the fact that I have created another pathway for the electrons to escape using my body. So as the negatively charged ruler is brought close, the electrons are repelled, and some of it escapes through my finger. Having a deficiency of electrons, the electroscope is now positively charged, causing it to stay charged even when we're not doing anything to it. I have charged the electroscope through induction. If I were to touch the electroscope once again, the electrons present in my body would travel into the electroscope because opposite charges attract. The positive charge of the electroscope will have attracted the negative charge of the electrons in my body, because only electrons move. And those electrons will continue to move until the electroscope is once again neutral. The aluminium leaves will then collapse because there is no charge, and I will have succeeded in earthing the electroscope by neutralizing its charge. Another interesting experiment is what happens when you bring a negative charge near an already positively charged electroscope. Again, we charge the electroscope through induction, making sure it gains a positive charge. Then, we bring the negatively charged ruler near the disc of the electroscope. As you can see, the aluminium leaves collapse. This is because the negative charge of the ruler has repelled the remaining electrons to the bottom of the electroscope, causing a neutral charge. Similarly, performing the same action with a positive charge can attract the remaining electrons, giving the leaves an even greater positive charge, diverging it immensely. A conclusion can be said that if the charge of the electroscope and the charge of the object are opposite, the leaves will collapse. If they are the same, then the leaves will diverge even further. The electroscope. This interesting project enables us to detect charge coming from an object and differentiate it as positive or negative, which I believe was so very fascinating to make, view, and explain.